So let's see the next topic, principles of IO software. Okay. So in the the first topic, goals of IO software. The goals of IO software. There are six goals of IO software. First one, device independence, uniform naming, error handling, synchronous versus asynchronous transfers, buffering, and shareable versus dedicated devices. Okay. So now let's see what is meant by device independence. Okay. So we should write programs that can access any IO device without having to specify the device in advance. Okay. So there are similar devices like hard disk, CD, and DVD RAMs. CD and DVD RAMs. Okay. So we should write a program. We should write a program without having to modify for each device. Okay. The program should not be modified for each device. That is, if it is a DVD disk or CD drive, DVD drive, or hard disk or floppy disk, hard disk or floppy disk. The read and write operation should be performed. Read and write operation should be performed. So that you need to write programs. Okay. So all these are IO device only. So that will perform read and write operation. So if you are writing a program, this particular program should be able to read write. Okay, should be able to read write in all the devices, okay, without modifying the program for each and every device. That is called as device independence. Okay. So then second one is uniform naming. Uniform naming, that means the name of a file or device should be a string of characters, should be a string of characters. So you are integer, characters are integers, and it does not depends upon any other device. Okay. So the name should be a string, with a collection of characters or a collection of integers. That naming should not depends upon the device. Okay. Then error handling. Then error handling. If there is any error that is occurred in a hardware device, either the error should be handled by device controller or your device driver. Okay. So for example, you are copying a block. That means you are reading a block of data. Okay. So if you find any read error, if you find any read errors, okay, the disk controller is trying to correct that particular read error. If the disk controller failed to correct that read error, then the disk device driver should able to read that particular correct that particular read errors. Okay. Next, synchronous versus asynchronous transfer. So we have seen previously synchronous and asynchronous. What is mean by synchronous? Synchronous means blocking, unblocking, block and unblock. Asynchronous means it works on interrupt driven transfer. Interrupt driven transfer. Okay. So most of the user programs, the IO operations are synchronous. That means it depends on, it will block and unblock. It will use the block and unblock operations. But most of the physical device, that means physical hardware, the IO that comes from physical hardware is asynchronous. That is interrupt driven. They are interrupt driven. Okay. So user programs are much easier to write if the IO operations are blocking. The IO operations are blocking. So it is up to the operating system so to decide how to transfer the data in a synchronous mode or asynchronous. That means the data should be blocked and unblocked, or the data will be dealt with interrupts. Okay. Next one is buffering. See, every device we already discussed, every device has its own device controller. The device controller has few amount of temporary memory that is present in temporary memory, that is called buffer, and a set of registers. A set of registers. These particular buffers, they are used for synchronizational memory. They are often called as synchronizational memory because not every device will have the same data rate. Okay, the transfer rate is not same for every device. Okay. So what will happen if you transfer the data from one device to other device? So you are transferring the data, so suppose device 1 to device 2. The transfer data of device 1 is 100 Mbps, but the transfer data of device 2 is not 100 Mbps, maybe 10 Mbps. Okay, so what you have to do before directly transfer the data to from one disk to other disk, because you can send 100 MB per second, this particular device might not able to receive the 100 MB of data because it can able to receive 10 MB of data. So first, this particular device will send the data to your device controller and store the data in the device buffer. So this particular buffer, device controller understood the knows how much amount of memory that can be transferred to device 2. Okay, so it will take the amount that will be transferred from device 2, that is 10 Mbps and 10 Mbps. It will divide the data, it will receive the data 100 Mbps, but it can transfer the data to 10 Mbps and 10 Mbps. Okay, so buffering plays major role in the system performance at the time of data transfer. Okay, then the resources, that is devices, will be categorized into two types. First one, shareable resources, and second one, dedicated resources. Which is dedicated means the resources which is not shared by multiple users. Okay, so shareable resources, your disk can be shareable, your disk can be shareable. Multiple users can open the files. Multiple users can open the files and modify the contents of the file. Modify the contents of the file. Okay, right? So, but when it comes to printers and tape drives, it is not possible to use by multiple users at the same time, because printers are dedicated resources. Printers are dedicated resources. Only one user can use the print, one user can use the printer. Okay, but the problem with disk which are shareable is that if multiple users are modifying the contents of this particular file, there may be a problem with incorrect data. Okay, or inconsistent data. The data may be incorrect or inconsistent. And when it comes to dedicated resources, the problem that comes is deadlocks. The problem that comes is deadlocks. We have seen what are inconsistent data, why inconsistent data occurs in a file, and also what are deadlocks. Okay, so operating system has to deal with both the problems of shareable that comes with shareable resources as well as non-shareable or dedicated resources. Okay, so the operating system is capable of handling both shareable resources and non-shareable resources. Then next one, interrupt handlers. Interrupt handlers. Whenever the interrupt happens, the operating system has to take some certain actions. Okay, so whenever the interrupt happens, the interrupt procedure takes required action to handle the interrupt. Okay, so then it can unblock the driver that has been started. Okay, so one, either of these three actions will be done. One, it will just complete upon a semaphore. Two, it will do a signal operation, signal on condition variable on a monitor. Three, it will send a message to blocked driver. It will send a message to blocked driver. In all the cases, interrupt will be driver that is previously blocked, now that can able to run. So this model works best if the drivers are structured and independent processes. Structured and independent processes. Okay, that means whatever the process P1. Okay, so P1 and P2 are there. P1 operation does not affect P2. Okay, does not affect P2. That means each and every process P1 will have its own stacks and have its own program counters, so that P1 and P2 should be independent processes. Not only P1, P2, all the process mostly are independent processes. It will be easy to handle the interrupts. Okay,